This is a question from AQA A-level Chemistry. It is a required practical question from paper 3, and this one is based on RPA9. I'm going to recommend that you pause on the question, have a go for yourself, and then review your answers. So, if I take a look here, we've got parts A and B. And now you've had a chance to pause and try it, let's take a look at the answers. So we've been given 4 pH curves, and there's a lot that you need to be familiar with if you're going to be able to navigate through this question. Let's take a look at how we can utilise our knowledge of pH curves to answer part A. So in the first instance, we are looking at what curve we would get if we added ammonia to hydrochloric acid. So we're adding ammonia to 25 cm cubed of hydrochloric acid. They are all 0.1 molar, so it's a 1-to-1 ratio. So we're looking for a change at 25. Now, actually, that's true for all of them. But if we also then think about the fact that with this, we are starting with a strong acid. So strong acid, that immediately takes us to B or C. And we are adding ammonia, which we've got to be aware is a weak base. So a weak base is going to rise up to a lower pH than a strong base. And we can see that that's the case on C. But also you can see that it's a shallower gradient over a longer period of time. It's not as vertical for as long. So the correct answer is C. If we move on and we take a look at adding sodium hydroxide to ethanoic acid. So in this case, we are adding a strong base. We would therefore expect our pH to go much higher. We can see both A and B are going up to pH of 13 or 14. But we're adding it to ethanoic acid, which is a weak acid. So again, that characteristic shape that we have starting at a slightly higher pH, and we've got this lip in there, which we hopefully recognise as a weak acid pH curve. So we are looking for A. And then we're adding nitric acid, a strong acid, to potassium hydroxide, a strong base. So we are getting that classic strong acid, strong base shape. And most importantly, because we're adding acid, the pH is going down. So B and D both show strong acid, strong base. But in D, we are adding the acid, and we know that because the pH decreases over time. Taking a look at part B, a table of acid-base indicators is shown below. The pH range over which the indicators change colour and their colours in acid and alkali are shown. You won't be familiar with all of these indicators probably. It doesn't matter because the pH ranges are what you can use to answer this question. Select from the table an indicator that could be used in the titration that produces curve B, but not in the titration that produces curve A. Well, actually, the answer we're looking for is bromocresol green, but let's have a look at why. Bromocresol green will change colour from yellow to blue over a pH range of 3.8 to 5.4. If we take a look on D, that is the vertical part of the graph. So we are going to get a rapid change in pH, which means we will get that colour change as a result of the addition of 1 drop. And if we take a look at A, where we're saying we couldn't use bromocresol green, 3.8 to 5.4, we've got a very gradual change in pH. That curve is going up very slowly. We're not going to get the colour change we need that's definitive to show us the endpoint is reached, so we couldn't use it there. Finally, give the colour change at the end point of the titration that produces curve D when cresol purple is used as the indicator. So cresol purple, what you're looking at here is for curve D, we're starting with an alkali and we are adding acid. So we're going to start with the alkali colour, which is purple, and we are going to go to the acid colour, which is yellow. So the direction is what we can see here. That takes us to the end of this question. Thank you for listening and goodbye.